to keep that going. All right, so we're going to evaluate a composition of functions, and we're going to find a composition of functions. We'll talk about domain a little bit. Not going to worry too much about it. Remember, domain's the x values, right? So you have combined functions by finding sums, differences, products, and quotients. Another way of combining is to form a composition, okay? So the composition of a function g with a function f is written this way. So h of x equals g of f of x is how we say that, g of f of x. So basically what we're doing is we're taking whatever f of x is and putting it into the g function when it's like that. Okay? So whatever f answer you get for f of x, you're going to substitute in to the g function for x. All right? So it's easy to understand once we do a couple of examples. All right, so this is the composition of g of f of 4 is what we're doing. G of f of 4. So what we need to do is the f of 4 first. Do that problem, and whatever that answer is, then we put it into the g function. Okay? So it's like two parts. It's like two problems, basically. All right? So the first thing we do is f of 4, which means to put 4 in place of the x in the f function. Right? Yeah. It just means to substitute 4 in place of x for the f function. What's 2 times 4? 8. Plus 1, 9. And what's the square root of 9? 3, right? Now we're going to take that answer and going to do g of 3 then. So whatever answer we get for this first part, f of 4, that came to be a 3. We use that 3 in the g function. I guess I don't want the arrow, I want equals now, right? So over here, x squared minus 4, which is 9 minus 4. So the answer is 5. So the answer to that problem, that composition of two functions, is 5. So you have to find one answer first, use that answer to help you find the answer to the problem. So it's a two-part problem, is basically what it is. Any questions on that example? Does that make sense to you guys?
Yeah, it does.
Okay. Why don't you guys try example 1b and see how you do. Oh, you got to be able to see it, don't you? Let me move that up for you. Hopefully we can. It's the same two functions, same f and same g. Okay.
Oh, Jesus.
When did it happen? First. Yeah. Collins, what'd you get?
The second part.
What'd you get for the first part?
Radical 5.
No. What do you do first? You guys did F, if you got the radical 5, you did F first. What are you supposed to do first?
I did G first.
You gotta do G first, right? What's that equal?
Do the bond equation first, 0.
You do this one first. All right, so we're doing this first. Here's the G, right? What's 2 squared?
4.
Minus 4. So the first part's 0, and then I put 0 here. What's 2 times 0 plus 1? 1, what's the square root of 1? 1. Okay? So this time, we're doing G of 2 first, which is 2 squared minus 4, which was 0. So then we're going to do F of 0, which is okay. So we're not always going to do like the first one. We did F first because that was here. All right. So do the one in the parentheses first. Okay. We got another one here. Okay. So let's move this up, and then see we can. Okay, and remember G of x was x squared minus 4, right? Isn't that what the problem was? The function G?
Yeah.
That was x squared minus 4, right? So that's all we need to know is that one. All right, so try that one. AJ, what'd you get?
0.
No.
I gotta get a 4. Negative 4.
Negative 4.
No.
I got that. You didn't get what?
Good job, Vincent. All right, first thing, okay,
So he's lying to your face right now.
what's that equal?
0.
That's 0, right? Negative 2 times negative 2 is a positive 4, not negative 4. Minus 4 is 0. So then we're going G of 0, which is 0 squared
I didn't.
minus 4, right?
I got that.
And 0 squared is 0 minus 4 is negative 4, okay?
Will you write this down?
Remember, when you're squaring a negative number, the answer is a positive, right? Some of you put it in like this, and it'll give you negative 4. Because the calculator thinks this is like a negative 1 times 2, so it does the exponent first. But really, we should be thinking about it this way. Okay? That's a mistake we make sometimes, okay? All right. Go ahead and do this one. F of G of negative 1.
Let me say H.
We got 3. Spencer? What'd you get? Well, let's go.
Okay. I'm trying to get my head right.
Get it now?
I got -1.
You are correct. -1. Question. All right, so this one, okay, we're going g of -1 first, which is -1 squared, which is 1, right? And then we're doing f of 1, which is 1 minus 2, which is -1, right? That makes sense? Let's see here. There's one with h. Let's move this up. There you go. Try that one.
I can't tell you. I can't tell you because you take my answer. Well, you've done it before, have we?
Oh, there it is.
You don't think you do. What'd you get? I won't do it this time. Here, cross my fingers.
Sophia. Sophia got 1. You agree with her?
Yes. Yeah, that's what I
That's
got.
correct.
I did get 1.
1 is correct. Okay?
Hey, then you copy off. Just kidding. Copy off Sophia. Copy off Sophia. This is like the one time. I don't understand.
That's -1, right? Then we're doing g of -1, which we just did up here, right? All right, we got this for now, right?
Yeah.
Okay.
Homework.
No, wait a minute.
Homework. Okay.
All right. Try that one. See what you think. No number, just x. Do the same procedure you've been doing. You're just going to simplify. You're not going to get a number answer. Put it in simplest form. Same procedure you just did. You just won't have number answer. You're just going to have some kind of expression. So what do I do with that? Like that, right? So what I'm doing is f of 3x minus 3, right?
Yeah.
Does that make sense? All right, so in the f function, I got a 5, and wherever I see an x, I put 3x minus 3, right? Now, do you do multiplication or exponents first? What's the rule? Exponent. So, what do I do when I have a negative exponent? I change the sign to positive, but what do I have to do to that number to make it a positive exponent? put a 1 over it, right? So this is going to move to the bottom. Now it's a positive 1. Can I do anything to simplify that fraction? No. I could, factor a 3 out. It's a GCF, right? But are there any factors that I can cancel? No. Now, it says state the domain here. Right? What number are we not allowed to have in a denominator? A radical or zero, right? Yeah. Imaginary is neither, right? Because an imaginary number is a radical, right? But anyway, 0 is what I was looking for. All right. So what number makes this equal to 0? 1, right? So x cannot be 1. So here's our answer. And this is part of the answer because when it's a fraction, we can't have 0 under the denominator. If there's a radical in the bottom, we got to simplify it, right? Got to move it out of the bottom. And remember, radicals, if it's square root or fourth root or sixth root, even ones, what did we talk about on yesterday's quiz? It's got to be what type of number? When it's even roots.
Positive.
Got to be positive or 0, right? 0 is okay, but positive. Can't have negative. So that's the things you look at for domain when you have denominators and radicals. Okay, so here's another one. Let me move it up so we can look at what our functions are. Can you see them? You still see it? Okay. So this time I'm putting this there, right? So this is g of 5x to the minus 1 power. And my g function is 3x minus 3. So wherever I see an x, I put that. Okay, now I got that. Here is just the x to the negative 1, or is the 5 also to the negative 1? This is important. Just the x, right? So the only thing that moves is the x, not the 5. You understand what I'm saying there? These two are different. Are these equal? Let me ask you that. Are those the same thing? No. Okay, see what I'm asking? Okay, so the only thing that's going to move in this one is the x. Here, the 5 and the x would have to move to the bottom. You see the difference? Okay, so that's something you got to pay attention to. Okay, so I'm going to rewrite this 5x to the negative 1 power as 5 over x to the positive 1. You see 5x to the negative 1 and 5 over x are the same thing, right? Are you with me on that? So what do I do with the 3 out front of the 5 over x? Yeah, I multiply it, right? So what's 3 times 5? So all I'm multiplying is the 3 and the 5. So there's my answer. What's x not allowed to equal? No, that's okay. 0.
Were you lying or were you both?
Okay. So when you don't have a number, in the parentheses, like we did the first few examples, when you have the variable x, you're plugging the whole g function into the f, or the whole f function into the g, and then you're just simplifying, like you know how to do. Okay? And then when we have fractions, we got to think about the denominator not equaling 0 as far as the domain stuff. If it's all in the numerator, we're okay. Domain could be anything. If we got radicals in it, then if it's an even radical, remember the number under the radical sign is 0 or positive. Okay? Let's do one more. I think you guys got this. All right? So G goes there, right? So this problem is f of 4x minus 3. You with me? And then f is 2, 4x minus 3, oops, not 1, but 3 to the negative 1, right? So wherever I see an x in the f function, I put that 4x minus 3. So what does the negative 1 make that 4x minus 3 do? Go to the bottom. Can I factor anything? No. So we're done. Okay, since that's in the bottom, I got to write that. So how do I solve for x there? What's the first step to get x by itself there? Add the 3. And then what? Divide by the 4, right? So that's the I like to call them restrictions on the domain, what x is not allowed to be. All right? So those negative exponents, to make them positive, we got to move whatever's being raised to that negative exponent to the bottom if it's in the top. If it's already in the bottom, we move it where? To the top. Okay? Pretty easy day, huh?
Yeah.
Okay, good job today. There's your homework.